Hi folks, Mr. Long here. I'm doing a screencast to help you interpret our work with intersections of lines and parabolas. So what I want to do is just point out to you, hopefully you can see the mouse moving over here. So the parabola that we've graphed is x minus 1 squared plus 6. The straight line that we're graphing, L, is mx minus 2, so the slope is variable. And then here's y equals p minus L, the parabola minus the line. That would be the distance between graph. And so what I'm going to do, the purple part is the parabola. Okay, the purple part is a parabola, and the line is mx minus 2. So if I'm going to change the m value, so you'll notice right now m is 0, so we have a horizontal line at y equals negative 2, and notice that the y-intercept is negative 2 on that line. So what I'm going to do is keep changing m. So there it's 1, there it's 2, there's 0 intersection points. M is 3. There's still 0 intersection points. Oh, look at that. M equals 4. There's a single intersection point. Okay, it's between the line and the parabola. Now, what I'm going to do right now is graph the distance between. So I want you to think about this. So parabola minus line. So out here, it's a certain distance. You know, right there, it looks like it's about 10 probably. And then here, what we can kind of see, that's at negative 2, that's 15. And right there, that's at negative 10. So it's actually 25 apart right here. Then it's less and less and less and less and less. And right there, at the point of tangency, the distance between is 0. As we move to the right, so let's look at x equals 6. At x equals 6, it looks like the height is about 22 on the red line, and the height is 31 there. So it's about 9 higher. So the height is 9, or the distance between is 9 here. Well, let's graph the distance between line. There it is right there. Okay, it's blue. And notice that in the same location where we have the point of intersection, that's where the distance between is 0. Okay, the distance between is 0. Now, if I take this right here, this M, and I move it off, so there's no intersection point, what do you notice about how the blue curve moves? Does the blue curve have any x-intercepts? No. The blue curve cannot have x-intercepts if there's no intersection point, right? There's always a positive distance between them. So as I make it even flatter, then we can see that the distance between, you know, it's just there's the parabola changes, but there's never any x-intercepts. So again, if I go back to 4, I have a single x-intercept, a single intersection point, and a single x-intercept, okay, at the same x value. Now, what happens if I make m steeper than 4, and now I get 2 intersection points? I'll just point them out right there. There's an intersection point, there's the other one. If I go down, you'll notice that the blue curve, the distance between, has x-intercepts where the line and where the purple parabola and the red line intersect. Okay. So if there's 2 intersections, then the distance between graph has to cross the x-axis. Okay, so I'm just going to take those or remove those. All right, so what I want to do is I want to have an idea here now, or give you an idea of how do we get a solution set for the values of m. Okay, so let's look first at what if there's one solution. Okay, so if there's one solution, then x has to equal 4, but what else does it have to equal? I'm going to turn the distance between graph off. So there's not just 1. I can turn this over here and make it have a negative slope. Oh, look at that. Looks like negative 8 has a point of tangency, right? So look at that. I go there. Yeah, there's a single point of intersection there. So if m is negative 8, we get another tangent. So m equals 4 generates a point of tangency, and m equals negative 8 would generate a point of tangency. Okay, so that's if we have one solution. Now, what about no solutions? Oh, whoops, daisy, I need to. So what about no solutions. Well, a slope of -8 gives no solution, or gives one solution, but a slope of -7 gives no solutions. -6, no solutions, and so on all the way around. So right here, all the way from a slope of -8 gives one solution. Now, what would a slope of -7.9 give? Well, I would have two intersection points, right? So what about a slope of, let's actually go back, -8. I think it's easier if we just do whole numbers. Okay, so -8, notice -7, so sorry, -8 has one solution, -7, 7.9, etc. actually doesn't have any solutions. So I keep going around, and then I come back to a positive slope, and then I get my one solution again at 4. Okay, so any slope between 4 and -8 has no solutions. So slopes between 4 and -8. So no solutions would be m equals from -8, not including -8, all the way up to 4, but not including 4. That's why it's round brackets. Okay, so I'm hoping that you can see those are no solutions. Okay, so then what about two solutions? Because two solutions is kind of tricky. Oh, don't want that. Okay, now we're going to do two solutions. This is the difficult one. Okay, so if I think about this, there's my one solution at -8. If I make it more steep, so -10, and I'm going to have to make this up to -100, and make this up to 100 here. So negative, 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 and really, I can go all the way from a slope of, -8, and then make it more and more steeper, but negative, right up to -infinity, right? So from -8 all the way up to a slope of -infinity. So -8 has one intersection, but anything steeper than that will have two. Anything steeper will have two. So in this case, m would equal from -infinity, from -infinity is a lower number, all the way up to -8. But it's also, m can equal, let's look at the positive side. On the positive side of things, we had 4 had one solution. If I then go steeper than 4, there's 6, 10, all the way up to positive infinity. So from a low point of 4 all the way up to positive infinity would generate two solutions. Okay. And so then m in this case would be the range of values from 4 all the way up to positive infinity, INF. Okay, so that's how you interpret things once you get those m values algebraically, which I think most of you can do now. It's the hard part is actually interpreting what range of values you would want the slope to be. So I hope that screencast helps you interpret those situations, and best of luck doing your homework.